Hello everyone. Today we'll be looking at condensation organic reactions. Now what happens in a condensation reaction? Basically what happens is we have two or more hydroxyl groups, these OHs right here, and they get excreted and form water. And whatever is left goes into the product. So basically, anytime you know it's a condensation reaction, you start with two or more hydroxyl groups, and you always know that one of the products is water. That's something that's very fundamental to condensation reactions, is water is always formed. It's always one of the products. Let me show you what that means. Here's our first example right here. We know it's a condensation reaction because we have two or more hydroxyl groups. And what they're going to do is they're going to form and create water. So we know it's a condensation reaction. Okay? And something we can always do, if you don't know where to start, is a systems analysis. That's always a good place to start and end your organic reactions. Let's see. How many carbons do we have on our reactant side? Well, we have 1, 2, 3, 4, 5, 6. 6 carbons on our reactant side. What else do we have? How many hydrogens do we have? Well, we have 3, 5, 7, 0 there, 8, 11, 13, 14. 14 hydrogen on our reactant side. What else do we have? Well, we have 1, 2, 3. 3 oxygen. Okay? Now what's going to happen, since we said this is a condensation reaction, we know that whatever product we have, one of them always has to be water. This is fundamental to a condensation reaction. Basically, if you see two or more hydroxyl groups and they're combining, you know it's a condensation reaction. In condensation reactions, water is always one of the products. So we might as well write that. And what do we have left? Now that we know water is one of the products. Well, basically, what happened was two of these hydrogens and one of these oxygens, basically H2O, combined to form the water. And what we had left was these two hydrogens were gone and one of the oxygens was gone. So we only had one oxygen left. So basically this hydrogen and this oxygen left to form water. And what we had left was one oxygen, and this carbon didn't have anything else, or this reactant didn't have anything else. So what they had to do was these two things had to combine so that all their bonds or all their needs were still met, because we lost an OH group here and an H here. So they have to combine to satisfy their octet rules. And we know whatever product we have, it's going to have 6 carbons on that side. So let's draw that now. One, 2, 3, 4, 5, 6. 6 carbons. Excellent. And remember that oxygen was in the middle, so it's going to be shared among the two groups. And we also had this double bonded oxygen right here. Can't forget about that. Okay? Now let's see. Did we do this right? Well, let's count. We have 1, 2, 3, 4, 5, 6. 6 carbons. Excellent. What else do we have? How many hydrogens? we have 3, 5, 7, none there, 9, 12, 14. 14 hydrogen on the product side. And then we have 3 oxygen. Okay? So whatever we started with is what we have to end with. And since it was a condensation reaction, 2 or more hydroxyl groups kind of formed. And one of the products we always know with a condensation reaction is water. And water was indeed formed. And whatever was left, they had to combine so that all their bonds were met. And we know we did it right because whatever we started with is what we ended with. Looks pretty good to me. How about we try another one? How about this question right here? Is this a condensation reaction? Well, although they're not attached to separate entities, yes, this is still a condensation reaction. Because remember, we have 2 or more hydroxyl groups that come together to form water. So we know it's a condensation reaction. And something we can always do is a systems analysis. It's always a good place to start. How many carbons do we have? We have 1, 2, 3, 4, 5. 5 carbons. What else do we have? How many hydrogens? We have 1, 3, 5, 7, 9, 11, 12. 12 hydrogens on the reactant side. And we also have 1 oxygen and 2 oxygen. 2 oxygen on the reactant side. So that's all we start with. 5 carbons, 12 hydrogens, and 2 oxygen. So they have to be somewhere in the product side. And we know, since it's a condensation reaction, something that's fundamental to condensation reactions is that water is always formed. Might as well do this. Create water, write down water as one of the products. And basically whatever is left is what forms into their own product. And we know whatever product we have, it has to have 5 carbons and everything else. Okay, so we might as well draw that right now. So we have 1, 2, 3, 4, 5. 5 carbons. Excellent. And basically what happened, let's say this hydrogen and this hydrogen made up the H2, and this oxygen left to make up the oxygen. Okay? So 2 hydrogens and 1 oxygen left to make H2O. And what did we have left? Well, we had that 1 oxygen that was left and all the carbons and hydrogens. And since they lost some of their stuff, they're going to have to form a ring or come together to satisfy their octet rules. And that's why these carbons came together. And did we do this right? Well, let's see. How about we do systems analysis? How many carbons do we have here? 1, 2, 3, 4, 5. 5 carbons. What else do we have? How many hydrogens? We have 2, 4, 6, 8, 10. Plus the 2 hydrogens here, 12 hydrogens. And then we have 1, 2 oxygens. And if you also notice, this oxygen formed 2 bonds, and that's because oxygen needs to form 2 bonds to satisfy its octet rule, and carbon has to form 4 bonds. Okay? So it's a condensation reaction because water was formed, and everything that was left formed into its own product. and we have the same number of reactants and the same number of products. Looks pretty good to me. How about we do one last one? How about this question right here? Looks hard, doesn't it? It really isn't. And I'll take you step by step through it. Okay. So is this a condensation reaction? Yes, it is. We have two hydroxyl groups. No matter where they are, as long as they're on the reactant side, we know it's condensation. So we have two hydroxyl groups right there, OH and OH. Okay? And that's going to form water as one of the products. Something we can always do, no matter what reaction it is a systems analysis. So let's count. How many carbons do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons on the reactant side. What else do we have? How many hydrogens do we have? Well, we have 2, 4, 6, 8, 10, 11, and that one right there, 12, 15, none right there, 16. Wow, what a big number. 16 hydrogens on the reactant side. What else do we have? We also have 3 oxygens. Looks like a 30, but that's just 3 oxygens. Okay? And we know, since it's a condensation reaction, these two or more hydroxyl groups come together to form water. Basically what happened was this hydrogen and one of the oxygens split off to create water as one of the products. And we know that is fundamental to a condensation reaction. Water is always one of the products. And whatever we have left, they're going to come together to satisfy their octet rules. Because we stole this OH group and one of the hydrogens here. So now they have to combine to satisfy their respective octet rules. So we know whatever we have on this side has to have 8 carbons. So what does that look like? Well, let's draw this ring again. 1, 2. So there's that ring right there. One of the oxygens was left over. And then we also have this right here. Okay. And that carbon basically just got moved over there. So, did we do this right? Let's do a systems analysis, shall we? How many carbons do we have on this side? We have 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons. How many oxygen do we have? Or sorry, how about let's do hydrogen first. How much hydrogen do we have? Well, we have 2, 4, 6, 8, 10, 11. None there. Sorry. Oh, there it is right there. Let's do that again, shall we? We have 2, 4, 6, 8, 10, 12. Okay, here, sorry. We have 2, 4, 6, 8, 10, 11, 14, 16. That's why it's always good to count your hydrogens and everything else, so you know you did it right. So we ended up with 6 hydrogens as well on the product side, which is what we started with. And lastly, oxygen. How many oxygen do we have? Well, we have 1, 2, 3. 3 oxygen. Basically, whatever we started with is what we ended with, which is good right there. And 2 or more hydroxyl groups came together to form water, which is fundamental of a condensation reaction, and whatever was left combined so that they can satisfy their octet rules. And whatever we started with is what we ended with. Looks pretty good to me. Well, that's it for condensation reactions. For more practice on organic reactions, please check out my other videos. Thank you.